All right, in Chapter 2, Section 2, um, it's talking about the end behaviors of functions. So I first probably want to go to Desmos and just look at some functions and what we're talking about when we say end behaviors. So if you have something that is to the first power, it's linear. If it's squared, it's a quadratic. If it's a cubic, it has its negative to the left and goes up to positive on the right. Something to the fourth power kind of looks like a quadratic. The fifth power kind of looks like a cubic. So we're kind of looking at the end behaviors. As x gets larger, the y value just goes to negative infinity. Or as x gets smaller in that case, the y goes to negative infinity. As x increases, it goes to positive infinity. If it's to the sixth power, we get something that looks like a parabola again. Now, what happens is what goes on in the middle. So here's a cubic that looks like that, but as I start adding things, I get some motion in the middle. And that's what goes on when we are adding those other pieces. We get some motion to it. Now, if I were to change this sign, it'd have the opposite ending behaviors. But if it's positive, it goes from left to right. It kind of looks like it's going up. If I were to add 5 to this, let's see what it did. It just kind of shifted up. It did a vertical shift. I'm going to make it a and use the slider. And so as I increase this, my graph goes up. Okay, see that better. And if I decrease that constant, it just shifts it down. So your constant at the end of one of these functions, these polynomials, just shifts the graph up and down. But we need to know these end behaviors of polynomials. So if you see a cubic and it has a positive number in front, it's going from left to right, going up to infinity, down to negative infinity. If I have something that's raised to the fourth power, it kind of looks like a quadratic. Let's give it some motion in the middle on this one. So that gave it some motion. Let's 2x squared. Let's change it to a positive. So again, it gives a little wiggle in there. Minus 5x. That changed a little bit. So again, it's not parabola because it looks like it's going up, but then starts curving more up here. If it was a plus, I just kind of did the other direction. That's neat. And then the constant at the end, plus 5, is just going to shift it up. So whatever that constant is at the end, it just moves it up and down, up and down. So we need to be comfortable on how these look. X cubed minus 3x squared plus 5x. They kind of thinned it out a little bit. Let's just do plus x. Still gives us some motion there. If I multiply it by a large number out front, it makes it's a vertical stretch. It's pulling it up. You could think of it as a horizontal shrink or a vertical stretch. So if I multiply it by 7, it gets thinner. Right? If I multiply it by a decimal number, this one would have gotten wider. So it looks like this. I want to do the 0.1. Like I'm going to back this thing up, and we'll see that it's gotten wider. So it's the same graph, just wider. Let's not go as dramatic. Let's do maybe a 0.5, and we see that it's gotten wider from just normal when it's a 1. Again, if you put a negative out front, it switches the graph. So just understanding the end behaviors, like if you have a negative cubic, as x gets smaller, your y values go to positive infinity, and x gets larger, your y values go to negative infinity. But if it's positive, it looks like it's going up eventually. So in this section they asked to do that. So here they asked you to find the zeros. And somewhere in here they talk about multiplicity. Multiplicity if you have a solution that happens more than once. And so we will look at that. If it has an even number of multiplicities, like if something happens twice, that's typically when it just touches the graph. Let's look at something that has a cubic that has a multiplicity of 2. And it's 2 because I'm squaring it. X plus 1. Plus 1. So we see that I have a solution of -1, 0, because if I set this equal to 0, I'd get -1. And I have a solution of +1. Now it's +1 twice, right? Because I have x minus 1 equals 0 and x minus 1 equals 0. That means it has a multiplicity of 2. This solution of 1 happened twice. And notice what it does to the graph. It touches it, doesn't go through it, then goes back up. If it's cubic, if it's an odd multiplicity, it will go through. So it went through 1. But if it's an even multiplicity, it touches the graph and then goes back up. It does not go through it. So it talks about some multiplicity in there. And again, I believe last time we solved one of these by factored by grouping, but I'll do a supplement for that. Let's see. Next one I want to look at is number 5. Find a polynomial function that has the given zeros. So 0, 1, and 30. And we kind of already addressed that. If it had solutions of 1, 0, and 30, that would give me a solution. 30 would be x minus 30. And then for it to be 0 as a solution, I would just have x, right? So that gives, I'm going to set x equal to 0, x minus 30 to equal to 0, and x minus 1 equal to 0 to solve those. So let us look at this thing, and let's go up to 40 so we see that other 0. And this can be taller. So we see it has a solution at 0, at 1, and at 30. And so we've done what the problem asked. And we could multiply these out, or with WebAssign, I'm pretty sure we could just type in this, and it would give us the correct value, or a correct response. Also for number 8, oh, I love these problems, these box problems. Let's set this up. So you plan to construct an open box with locking tabs from a square piece of metal, so M is 24, on a side by cutting equal squares from the corners and folding along the dashed lines. So we're cutting these squares out, right? So it looks right there that I've cut out, that looks like I've cut out 2 x's if I'm going across. 2 x's here and 2 x's here. So this length, that inner length, looks like it would be M, that 24 distance, minus 4x, where this length would be M minus an x there and minus an x there. So if I was trying to find the volume of this box, I see that I would have a length of 24 minus 4x, and I see that I have a width, so this would be 24 minus 4x, because I'm subtracting 1, 2, 3, 4 length of x's. So that piece from here to here would be 24 minus 4x, and then this piece, whatever you want to call it, width or length, would be 24 minus that x and that x, so I'd have a 24 minus 2x. And then the height of this thing, since they're folding it in, the height is just an x. Now that's not what they have, but I guarantee you those are similar. This one if you factor out a 4, this one if you factor out a 2, 4 times 2 is that 8. And so my answer would be fine. But that's how you would construct this volume equation. So I'll make a supplemental video for number 4, just making sure that we recall how to solve one of these by grouping. And that should give you a good head start for section 2.